Now the fun begins. Now we're going to actually use all these definitions and find critical values and then use the critical values to find extrema. So this is what we want to be able to do. A couple definitions though, just to recap. I know. All right, so critical numbers. Remember, to find the maximum and minimum of a function f on a closed interval a, b, we need to find all the critical numbers. Critical numbers are these c, what I'm calling c values. So we have little c1, c2, c3, c4, up to cn, where these are all x values on the open interval a, b. So to find those, we set the numerator and denominator of the derivative f prime equal to 0 and solve for x. Then all we're going to do is we're going to compute what is f of a, what is f of b, and then what is f of c1, c2, c3, c4, and so on, to find the largest and the smallest value, to find the absolute maximums and minimums on the closed interval a, b. So whatever value comes out to be the highest, that's the maximum. Whatever value is the lowest, that's the minimum. If we have a tie, then we have two locations where the maximum or minimum occur. All right, so let's do this. Find all the critical numbers of the function f of x equals 2x cubed minus 21x squared plus 60x minus 4. So you'll notice on all these examples, we're first going to talk about the domain as well, because if something's not within our domain, then we don't care about it as a critical number necessarily. So when we look at this function, what do we notice about that function? Come on. Nobody? Come on. It's polynomial, right? Okay, so if it's a polynomial, then what do I know about the domain? Negative infinity to infinity, or all real numbers. Okay, so that's good. Next up, derivative. What's the derivative? Derivative, we're going to use our power rule, 6x squared minus 42x plus 60. Okay, good. That's our derivative. Now what? Well, what did it tell us to do? It said to set the numerator and denominator of f prime equal to 0 to find our critical numbers. There is no denominator here, so we are just going to set the numerator equal to 0 and solve. So if I set this equal to 0, let's see, we're going to divide everything by 6, because everything has a factor of 6, right? Yeah, so x squared minus 7x plus 10 factor. We're having fun now. Still having fun. Always having fun. Math is fun. Math is life. Life is fun. Whoops. Messed up. So we end up with x equals 5 and x equals 2. These are what we call our critical values. Boom. Questions? No? Good. Moving on. All right. So I want you to try this one on your own. Find the critical numbers. First, identify the domain though. Domain's important. Find the critical number, so find the domain. Take the derivative, find the critical numbers. Pause the video, unpause when you're ready to check. So here we should end up with the domain is negative infinity to 1, 1 to infinity. Do the derivative, so I did the quotient rule, so bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Simplify a little bit. But then to find our critical values, remember we are going to set the numerator and denominator equal to 0 separately. So I did that over here off to the side. I factor, I get x equals 0, x minus 2 equals 0, and x minus 1 equals 0. So I end up with critical values of x equals 0, x equals 2, and x equals 1. Hold up. This is where the domain was important. So in order for something to be a critical number, it has to be a value that actually exists on the function. So our domain was negative infinity to 1, 1 to infinity. So actually, x equals 1 is not a critical value by definition. So only x equals 0 and x equals 2 are our critical values. Let's try another one. So fx equals x plus 4 to the 2/3 find the domain, find the derivative, find the critical numbers, pause the video, unpause the video to check. Here we get a critical value of x equals -4. How do we come up with that? First, let's think about the function. Okay, so this is x plus 4 quantity squared and then cube root, right? That's what the 2/3 means. So the domain's all real numbers, so we don't have to worry about that. Take the derivative, so I do my chain rule, so power x plus 4, -1/3, derivative of the inside. All right, then I just rewrote this a little bit so I can see what's the numerator, what's the denominator. Set each of those equal to 0, but since the numerator is just 2, I don't have to worry about that. That's nice. Set the denominator equal to 0, solve for x, and I get x equals -4. That's my critical value. Next, okay, let's take this a step further. Let's actually find the maximum and minimum of f on the interval -3 to 1. So first, let's talk about the domain. Well, this is a polynomial again. Very good. Glad you pointed that out. But we're only looking on the interval -3 to 1. So when we were talking about our domain for this problem, although a polynomial has a domain of -infinity to infinity, we're really just looking on the domain -3 to 1. Now we do want to still understand that the domain of this function was all real numbers, so the function exists everywhere between -3 and 1. Okay, good. Find our derivative, 3x squared minus 6x minus 24. All right, now we set the derivative equal to 0. 0 equals, divide the whole thing by 3, so I'm going to get x squared minus 2x minus 8. And now we can factor. Plus 2, move down, and so now we can say x minus 4 equals 0, x plus 2 equals 0. I'm talking to myself because I'm the only one here, but you are listening to me because you are watching the videos of that. So we get critical values of x equals 4 and x equals -2, but remember, we were only looking on the interval -3 to 1, so we are going to, my bad, ignore this as a critical value. So now we need to find the maximum and minimum though. So this is where we just use the critical values and the endpoints. So we're going to find f of -3, f of -2, and f of 1. So if I use my calculator for these, f of -3 is going to equal 20. Sorry, I already did these calculations. F of -2 is 30, and f of 1 is -24. So what did we find? We found this is the max, and this is the min. Any questions? No? Good. Nice work. I'm proud of you. I'm proud of me. Proud of all of us. I want you to try this one on your own. Find the maximum and minimum on the interval -1 to 3 of this function. Pause the video, unpause when you're ready to check. Hopefully you came up with the fact that f of 0 equals 0 is the maximum, and f of -1 equals -5 is the minimum point. How do we come up with that? Well, okay, so we know that, again, this function itself has a domain of all real numbers, but we're only looking on the domain -1 to 3. It's important that we recognize this didn't have any points of discontinuity, though, so we know this interval is good. So, and then I do the derivative, just did my power rule. Rewrite this to get rid of the negative exponents, get a common denominator, because when I set the numerator and denominator equal to 0, it's going to be very important that I have just a single function when I do that. So 2 cube root x minus 2 equals 0, and cube root of x equals 0, so I get a critical value of x equals 0, and here I get a critical value of x equals 1. So then remember, I need to test my endpoints, and both of those are within my interval, and I need to test those points. So I plug in -1, I plug in 1, I plug in 0, and I plug in 3, and I get 0 as the largest number, -5 as the largest negative number. Okay, so keep in mind, everything that we found here when we were talking about maximums and minimums was absolute maximums and minimums, because we were just finding what is the highest point and what is the lowest point. But in some of those situations, we also found a relative maximum or minimum if it was within the open interval. So if we look back at this last example, uh, so -1, -5, that's an absolute minimum. It is not a relative minimum because we were only looking on the interval -1 to 3, and that was one of the endpoints. That would be on a closed interval. But f of 0 equals 0, that is an absolute maximum and a relative maximum because 0 is within the open interval -1 to 3.